When we talked about data types, we introduced the concept of variables. Variables are reference names to a specific storage location that holds a particular value of the data type or the type of data. The value or content of this storage location could change over time in the program. For example, look at this slide. If we introduce a variable named total of data type integer, we can see how to increase the value by adding, for example, 1. So in this example, we have total equals total plus 1. The value of what is stored is now 1. However, the name of the variable remains the same. It's important to highlight that in C++, the name of the variable, which is also called the identifier of the variable, is a sequence of one or more letters, digits, or underscore characters. Spaces, punctuation marks, symbols, those cannot be part of the identifier or the name of the variable. In addition, identifiers shall always begin with a letter. You cannot start with a number in C++. They can also begin with underscore characters, but in such identifiers are, on most cases, considered reserved for compiler-specific keywords or external identifiers, as well as identifiers containing two successive underscore characters anywhere. In no case can they begin with a digit, like I said before. C++ uses a number of keywords to identify operations and data descriptions. Therefore, identifiers created by a programmer cannot match those keywords. The standard reserved keywords that cannot be used for programmer created identifiers are, for example, a line off, and, ASM, auto, class, do, double, float, for, friend, go to, if, int, int, operator, or, and so on. Specific compilers may have also additional specific reserved words. But it's important to note that in C++, it is a case-sensitive language, which means that the identifier written in capital letters is not equivalent to another one with the same name but written in small letters. In the example here, where we have total as the variable or the identifier name, with a capital T, if we change this with a small t, this is a different identifier or a different variable. But what if we want to reserve memory space for a specific data type and we want that value to be constant? Then to do that, before the identifier name that we use, we have to use the keyword const, C-O-N-S-T. You can see it on the screen. As an example, in line 1, we have a variable called pi. The data type is double. You see it by a blue keyword. And before the keyword double, we have the keyword const, which is indicating to the compiler that this is a constant variable of type double that will be holding a specific value. Line 2 has the same similar example, but the data type here is char. The variable name assigned by the programmer is called tab. So constants are expressions with a fixed value. These do not change. Following this const, this keyword for constant is the data type, the data type keyword. And what's on the right hand side of the equal sign is the literal value. This is the actual value that will be assigned to that memory space that is referenced by the word or the identifier tab or the identifier P. So this is also called a literal value. So in the example of P, it is saying that P will have a value of 3.141596 as the value that will be stored to that variable P. There's another way to assign the constant values to variables in C++. And you see it in line 4 and 5 using the preprocessor definitions. To do that, you write the pound sign, then the define keyword, and the identifier replacement. So in this example, we could have written line 1 as pound define P and 3.14159. So what is it saying? That it will assign the value of 3.14159 to the value of P. The difference here is that once the pound define or this directive identifier is inserted, any occurrence of the identifier in the code is interpreted as replacement, where the replacement is any sequence of characters until the end of the line. So, and as such, a single line instruction that, unlike C++ statements, do not require semicolon at the end. So the directive extends automatically until the end of the line. If a semicolon is included in the line, it is part of a replacement sequence and is also included in our replace occurrences. Which means if I would put a semicolon at the end of 3.4159, it would assume that this semicolon is included in this value that will be replacing P. So in this case, because we're using the pound define, any value that is following the identifier P up to the end of the line is assigned to P. So we've introduced variables, we've introduced constants, we've showed how to define constants by using the const keyword or the pound define. Now we can begin to operate with them by using operators. So what follows is a complete list of operators. At this point, it is likely to, or likely not necessary to know all of them, but they are all listed here to serve as reference. The assignment operators is what assigns a value to a variable. So it's the equal sign, as you see on the slide there. For example, we could have x equal 5. The variable x is being assigned the value of this literal 5. The statement assigns the integer value to the variable x using the assignment operator. It's important to note that the assignment operation always takes place from right to left, meaning whatever on the right is assigned to the left, and never the other way around. We have arithmetic operators such as plus for addition, the minus for subtraction, the asterisk for multiplications, divisions, and modulo. The percent sign here is the modulo. And the modulo is used to give the remainder of a division of two values. For example, if we had x equal 11, and then we have the percent here, we're saying what is the value of the remainder once 11 is divided by 3. And we know 11 divided by 3 is 9, and we have a remainder of 2. So therefore x, and after this arithmetic operation completes, would be 2. Okay? We have also compound assignment operators, and they modify the current value of a variable by performing an operation on it. They're equivalent to assigning the results of an operation, of an arithmetic operation, to the first operand. Some expressions can even be shortened more, and we'll see them in a little bit. So I'll give you an example. For example, here, where we have y plus equal x, it is equivalent to y equals y plus x, using the compound assignment plus equal. Like we said, we could even shorten some by using the increment and decrement operator, plus plus or minus minus. If we would have x equal 1, and we had plus x, for example, using the increment operator, this would be equivalent to having the compound assignment operator x plus equal 1, which would be equivalent, both of these, to x equals x plus 1. And we know that x equals 1, so the value of x at the end would be 2. There are also operators for relation and comparison. If we want to know if two values are equal, if one is greater than the other, if the other is smaller than the other, these comparison operators, or these relational operators, return the value of true or false, which is a Boolean value. For example, if we would have 7 equals 5, it is trying to determine if 7 is the same as 5. Of course, this results or evaluates to a false because they're not equal. If we would have 3 not equal 2, this would evaluate to true because 3 is not equal to 2. If we would have 5 is less than 5, this will evaluate to false because 5 is not less than 5, and so on. So here in this table, you have the list of all the relationship and comparison operators. We also have logical operators. For example, the AND operator and the OR operator. And the table tells you that how it evaluates. If we have a variable A being true and a variable B being true, the result of A, the operator and B, gives you true. True and true gives you true. True and false gives you false. False and true false. False and false false when you use the AND operator. So an expression A and B would evaluate to true once you have A equal true and B evaluating to true. The OR operator, on the other hand, once there is a true, it evaluates to true. And you see it on this table right here. The conditional operator evaluates an expression, returning one value if the expression evaluates to true, and a different one if the expression evaluates as a false. Its syntax is here, condition, question mark, result 1, result 2. Okay? So the condition is before the conditional operator, question mark. As an example here, we could say 7 equals 5 plus 2. So we're writing the condition. Remember, we're not assigning here, we're just condition. This is true. Is this equal to this? Will this give me a true value? This evaluates the true. So the conditional operator would follow, which is the question mark. And then we'll say, okay, if it's true, will be 4. If it's false, it will be true. So the answer would be that it evaluates to 4, because we know that 5 plus 2 gives you 7, and at the end 7 and 7, they're the same. The typecasting operator, basically what it allows us to do is to convert a value of a given data type to another one. And you see there in the examples in line 1, 2, and 3, that excerpt of a code in C++. So we have a variable of type float, variable f, which is value 3.14. We're casting that variable to type int and putting the result into I, which was a declared variable of type int. So at the end, because a floating value has decimal places and an integer value doesn't, the answer of I would be 3, just the 3. Note that the casting operator basically is using the expression or the data type and putting it into parentheses. That's how it's used. So that is the way, just by enclosing the expression between parentheses. The size of operator basically gives you, it accepts a parameter and gives you the size of that. So in the example here, we have a x getting the size of char, because char is a character. X will be given the value of 1 byte. And then this table has a list of precedence of operators, meaning what operator is the one that would be executed first, which has the higher precedence. And you could see the levels, meaning the higher preferences, and the operator that follow, the description, and so on. That concludes our lesson on operators for C++. Just a clarification, what I wanted to say when I said that 11 divided by 3 equals 9 was that 11 divided by 3 equals 3, 3 times 3 equals 9, and that's where we get the 11 minus 9 equals 2 for the remainder, which was what we're interested in the modules. Thank you very much, but I think everybody understands it clearly.